Hello again and welcome back to the Func Prog podcast with me, Christopher. Before we start, I have some exciting news to share. Func Prog Stockholm is hosting a functional programming conference. It's a half-day conference right in the middle of Stockholm, completely dedicated to just functional programming. It's on the 15th of October. We have 3 speakers lined up. There's going to be food, music, we're going to have a panel discussion. I think it's going to be a ton of fun. I'm super excited about this. But yeah, so now you have to go tell your boss that on the 15th of October there's an important event happening, an important conference that you need to go to, which is crucial for your personal and professional development. Even if your boss won't pay for you, that's no problem, because we priced the tickets very, very affordably. We wanted everyone to be able to go to this conference. So tickets are actually just 500 kronor per person, and we also have a limited amount of early bird tickets that are just 400 kronor. To get tickets and more information, go to funcprogconf.com. In today's episode, I'm talking with Peter Strömberg, also known as PEZ. He's the creator of Calva, a Clojure environment for VSCode, and he's been programming since the 1980s when he got started on his week 20. But since then, he's done a bit of everything. For a while, he switched to project and product management until he found Clojure, which turned him back to programming. So, without further ado, here's my podcast with PEZ. Hope you enjoy. The reason I wanted to bring you on the podcast is that I've been talking to a lot of people about statically typed functional programming. And I want this podcast to be fair and balanced. So I want
this dynamic type guy.
Yeah, or at least one of the reasons I wanted to bring you on the podcast is so we could talk a little bit about Clojure. Over to you, Pez. What is Clojure and how did you get into it?
Yeah, so it is connected to me switching from product ownership to being a programmer, because it was Clojure that brought me back. It brought the joy back of programming, and I want to do this. So it's a very, very connected. So that's one thing that Clojure is. It's a very fun language to work in. It's a very general purpose language. You can use it for anything. It's very well designed. I mean, people who choose it, they do it very often for reasons. It's very well defined, extremely thought through. Very deliberate decisions going into the language. Rich Hickey, the creator of Clojure, really had a focus on what kind of problems he wanted to solve with this, with that other programming languages had that he wanted to solve. So it might be different decisions than other popular languages has taken. So it's very, it's opinionated in that sense, I would say. It's functional first, and it's immutable first. But maybe I am repeating myself. I don't know.
Yeah, I mean, not necessarily, because Clojure is a Lisp, right?
Yeah.
And I mean, they come in a bunch of different flavors. And I guess to the outsider, the most significant thing about the Lisps is that there are a lot of parentheses.
Yeah, and Lisps are not necessarily functional, right? It could be object-oriented Lisps or whatever. So I guess many Lisps are functional, but there's no equality there.
Yeah, and if you wind back the clock a bit, you have on one hand you have Scheme, which is this kind of quite elegant and theoretical that's flavor of Lisp that came out of MIT, I think.
I think so.
Yeah, also made famous by the Structure and Interpretation of Computer Programs book.
Exactly.
Which is a classic in the genre. But I mean, then there was also like, you know, Common Lisp, which is like you said, it has an object system, and it's not very like does not focus on like immutability at all. So it's like very.
No. Is Scheme that?
Scheme is. I think Scheme has support for mutability, but I think like. I'm mostly guessing, but I think it's more supposed to be much more functional, much more mutable, a bit less focus on like macros than. I mean, Common Lisp is like, or at least Common Lisp advocates like to bring up like, you know, the powerful macro system, like the fact that you can sort of rewrite Common Lisp to become any language you want, pretty much. That's a strength.
So if we compare a bit there with Clojure then, because it's a Lisp, we can like establish that, but it's not theoretical in any sense. It's very, very practical. And when it comes to like data, it brings literal data structures in. So it's in a Lisp, you would have those cons cells, and you do all those kind of manipulations on them, but in Clojure you never see them. I don't know if they are there even. Like so, it's instead it has these literal data structures. So you have maps, you have vectors, and you have sets, and you have like very strong literal representation of them in your code, and then you also have something called a sequence abstraction.
Okay.
It's super powerful. So I think the sequence abstraction has like first rest, first rest, and maybe there's something more. But it's anyway. You use that. Everything, if you have a collection of any type, you can treat it with every function and every piece of your library that support these sequences. So it's super. It makes the standard library of Clojure, which is called Clojure Core, extra powerful. It's a very rich standard library for manipulating data, and that's interesting because it's a very small language. I guess it's like Scheme. I'm just guessing Scheme is a small language.
Small and elegant. At least that's what they say.
And Clojure is small, and I would call it very, very elegant. It gets a bit deviating a bit from Lisp's traditional, but introducing these literal data structures is also introducing some new syntax. So it's not all parens, it's also brackets and curly braces. And since it's a Lisp and it's homo-iconic, right? So also the Clojure language you write also with these both parens and brackets. So it's not as like loaded with parens as Lisp programs could be otherwise. I think very often if you compare like it's the same thing solved in JavaScript and in Clojure, there are fewer parens in the Clojure version. And that comes back to these like the literal data structure and the literal and the new syntax in Clojure in that sense, but also macros. You mentioned macros because as a Lisp, it is like natural that since it is homo-iconic and like expressed, the programming code is expressed in like data. So it's very manipulative. So it's manipulatable.
It's very easy. Like, I mean, I guess the classic like meme is that in Lisp everything is a list, including the program itself.
Yeah, so exactly. So including the program itself. So you can manipulate the program itself, and that's what you do with macros. So it has a very powerful meta-programming space, right? But traditionally, or at least since I entered Clojure, which is like 8 years ago, something like that, it is not very common that you solve your business problems with macros, like it is in Common Lisp. So in Common Lisp, you create like a new language for every problem. That's what I heard. But in Clojure, you're much more relying on data. And macros are mostly for the Clojure library and other libraries. In libraries, they are very popular. So you have very powerful macros that make solving your problem so much easier. Because that's like a thing that why I found Clojure so fun. That was because I got so productive in it. Yes, I mean, the REPL and everything makes it fun, but it's also you get very productive because your program, almost everything, when you look at your program, almost everything is about the problem. It's very few things in your program is about solving like the problems of the programming language or whatever other stuff you're solving in traditionally. So very often, like if you compare a Java has come a long way, but traditionally Java and Clojure, if you compare two solutions, it could be like 20% of the code or something like that you had in the Clojure program, because it was only solving the problem, and the Java program was like, as they say then, solving the problem with 1/5 of the code, and the rest was solving the language problems.
Okay, so and when you say language problems, it's like, to get around like limitations of the language, or?
No, I'm more talking about like bullshit that the language is putting up. Like you must have a class, and you must put stuff in there, and there must be some like declarations and types, stuff like that.
Yeah, because and this is something that's quite interesting. Like, I mean, just like, as for the record, I haven't coded like that much Clojure. I mean, I've been following it quite closely for quite a long. I don't remember. It came out in 2005, right? Or 2007?
2007, I think it was released.
Yeah. And because I was always like, ever since Paul Graham was writing those Lisp essays, I was like, wow, this sounds so cool. And but I got the the Common Lisp book and everything, but it was like, just getting it to run felt a bit like obscure, so I never really got into it that much. But then Clojure came along, and like you said, this was like, wow, this feels like super pragmatic, because it runs on since it runs on the JVM, you have like all of those Java libraries should you need them. Like, I mean, it's a bit annoying to sort of have to write like an XML parser from scratch, for example. But then and like the JVM runs pretty much everywhere, so you have like the portability and everything. Still though, like I did dabble a bit, but never really got into it like that heavily. But something I found interesting was this, like you said, this philosophy of like everything is data, right?
Yeah.
And like this idea of I think you could call it like data oriented programming, or
we use that term a lot, and even data driven at some in some contexts.
Yeah,
but it's very very data oriented, and I think when I entered Clojure, it was like in a shift. It was macros was more popular back then. But then the community has switched over to mostly using data. And you mentioned the JVM, so that's another thing about Clojure. It's hosted, so and it's very close to its host. So you have like the host, right? write in your expressions. So it's very easy to interrupt with Java and the Java libraries and stuff like that. But you also have Clojure for the CLR. You have Clojure for like JavaScript, for Dart, Python. So there are several like hosts, and there is one in the works now called Jank that is going like to be hosted on the LLVM. Or, like in the C++ host.
You can sort of compile it to like native code, or
that's going to be compiled into native code. And it's also, which you might find extra interesting, it's gradually typed. So it will have like static typing. Gradually added. So you can still write a totally non-typed program, but then you can add type as much. A bit like TypeScript, JavaScript philosophy, yes, I think, around that. But then you also have Clojure. You have an interpreted Clojure called Babashka. And there is a version of that called Node Babashka, MBB. You can like take Clojure to new places in a sense. Like if you want to have Clojure in your shell scripting, that wasn't really feasible before because it needed to like fire up the JVM and then fire up the Clojure runtime. And if you have that
takes a bit of time.
Tight loop, then you couldn't use Clojure there, right? But with Babashka, it has like 0 startup time, so it's very. I do a lot of my shell scripting in Babashka these days. And the same guy who did Babashka and NBB, he also is working on the Clojure script side of things with like a new take on Clojure script. So Clojure script is like compiled to JavaScript, so it's hosted on the JavaScript. But he's working on something called Squint, which is more transpiled Clojure script. So you write in Clojure and then it transpiles to JavaScript. So then there is no. It's very different because if you code in Clojure script today, you still have to have Java and compile. The Clojure script compiler is a Java program, and everything is like Clojure like below, right? But with Squint, it's more like it's like another way to write JavaScript rather. It's very very interesting.
Yeah. And it's Michael Borkent, he's the mastermind.
Bork dude.
Bork dude.
Yeah, exactly. He's very prolific. I mean, it's they talk about like 10x programmers, but this guy is 100x programmer.
Yeah, he's very prolific. Like he has a lot of ton of cool libraries and stuff.
Yeah.
But can we talk a little bit more about like data oriented programming, like the philosophy behind it, because I find it quite interesting because like the idea is like everything is data. Like I mean, if I have my domain objects, they are data, and like but what are the consequences of this? Like in working with this in practice.
Yeah, so I guess it is exactly that, what you were talking. You model everything as data. So, okay, I have this problem, and then you're like want to model it. Then you think in terms of like data structures, and then you try to keep like everything of your program working with the data. So it's like pure functions gets data in and out comes that and version of that data or whatever part of that data, augmented data, whatever. And
it's just maps and lists basically. That's the key, right? Maps,
vectors, sets, and lists. Lists are not so common in Clojure. You have like sequences, but you don't really care if those are lists or whatever. They are sequences.
It's just a lazy abstraction, right? Over like some kind of
you have lazy sequences as well. So it's and Yeah, that's also a thing with Clojure. That's a lot of things like result in lazy sequences. So, and I think that's, yeah. If we talk about like the bad things about the language, so maybe you could wish that it didn't like give you lazy sequences so as often as it does, right? That you had more of you would need to ask for the lazy sequences.
Okay, so what's bad about the lazy sequence?
Yeah, so I mean, lazy sequences are awesome if you're not going to traverse the whole sequence. So if you was just you have a sequence of something, maybe it's infinite, then it's awesome that it's lazy.
Yeah.
You don't want to. But even if it's just large, and you just want the 5 first things of it, then you don't want to have like the whole thing realized. It's great that you just realize the 5 things.
Yeah.
But if you're going to work through the whole data, then there is an overhead that comes with it being lazy, performance overhead and other overhead. And you pay that even though you are actually going to go through the whole sequence, right? So, and also they are like hard to print and look at, and we haven't mentioned interactive programming so far, and we have been talking about Clojure all this time. So in Clojure, you try to like be connected to the running program. And if you have been using Common Lisp or Smalltalk or some of those systems, then you know what interactive programming is. Because it's like your programmer, you as a programmer have like access to the running system. In Clojure, it is just a program that you're working with. In Smalltalk, it is the whole everything that you're connected to. And also, I think in Common Lisp, it's also that you're like connected to some image or something like that. But in Clojure, you're connected to your application. The application has actually been created by the REPL process, right? It has read each form one by one, compiled them, and step by step, like built up a program. And then you continue to work with the program in the same sense. Right? So, okay, now you have a program running. You want it to behave a bit differently. So then you evaluate a new version of a function it already has, or you evaluate a new function that it doesn't have, and you like plug that into it, a namespace, and then you can call it from some other function, and you do all this without restarting the program. So traditionally, you would have another kind of cycle, like you have a program in code, and you can run that program and look at what it does, and you want to do something else, then you change the code, you recompile it, and you run the program again and see what it does. You don't do that with Clojure. You can, but you don't, right?
Yeah,
so
shouldn't.
Instead, you're like have the program running. You're inside that. You can inspect everything about it, and you can make it do new things while it is running. So it's a conversation in a sense between you and the program you are building. So it's very, very nice. And then when you are in the REPL, when you are looking at something in your system, it is awesome if it is data. So if it is something else than data, you can't look at it. If it like a function comes like it's opaque. You can't look at the function. You can't examine it. But if it's data, then you can look at it. So it's it has also to do with that, like data in Clojure by default is immutable. So you're looking at this data at like this point in the program, and it is not changing when you're looking at it or whatever. So in JavaScript, if you console log an event object, and something happens, you can see the object actually is changing in the console log. It's totally like crazy.
Yeah.
It's powerful, but it's crazy too. So in Clojure, if you have everything as data, it is immutable, and that is a lot of benefits come from that. So if for instance, if you want to implement undo, redo functionality, you just take a snapshot of your data and save it. And then the user does something else, and you take a snapshot of that data, save it. And if you want to undo, you just like swap out on the old version of the data. So it's very easy to implement stuff that is harder to implement if the data is actually changing. So it's I think we were talking about it like value semantics. So Richicki philosophy to that is that a value never changes.
A value is a value. The value of values, one of his classic talks.
Yeah, exactly. So and that means like you can compare like two data structures, even if they're pretty large. It's reasonably cheap to compare them. It is also reasonably cheap to keep two versions that are very similar of the same data, because you're not actually copying the whole old data structure and making a new one. You're just like copying the root or top node of it, right? And then the thing you change in that tree gets to point to a new place, right? But the rest of your data structure is actually shared. So it's a very
like persistent versus ephemeral data structures, right?
Yeah, it's persistent data structures in Clojure, and I think that was like an idea that had been around for quite a while, but never really used before Clojure implemented it, and Richicki implemented Clojure. Maybe Haskell.
Yeah,
I don't know the history, but I think Haskell also has.
Yeah, I think they probably use it as well. I think the idea was popularized in a book called like Purely Functional Data Structures, I think, by Chris Okazaki. And I think most functional programmers use some kind of variation of like a tree structure with like that's also like persistent, where you basically only changed you keep around you have like common references to like the shared parts of the tree.
Exactly.
And then you can make small incremental changes very efficiently, and like but and I think that like the OG like persistent data structure is the linked list, right? Because that's like sort of the prime example of something where it's very cheap to make a copy of it. That's almost like you can like incrementally change it without having to reallocate the whole list every time. Like, it's very easy to have like, copies that sort of share structure without eating up tons of memory.
Yeah, you're probably right there. So data oriented. I guess it's a way to you can go to some length actually to make sure that your data or your program, like at the core, is pure and only deals with data, and then like at the edges of this program where you're interacting with the system that's putting data into the system, like that is like a thin layer.
Yeah, like a thin layer.
And it like what it does is like it turns that ugly mutable world outside into pure data, and then your program just only deal with data. So if I can sense when I have managed to get a system to be fully data oriented, to where I can see that on my unit tests, because the unit tests don't have any mocks.
Okay.
Right?
Yeah, so
You don't need to mock
data
anything inside.
Yeah.
It's like you don't need to mock data, right? Data is data. And so in a sense, I have this feeling that if I have a mock in my system, then something is wrong. And then I go, depending, could cost too much sometimes, but depending, I often take some time to get rid of that mock and make sure that part of the system is data oriented enough for me to not having to deal with the mock. The database shouldn't be in your core business model.
Okay. So basically, from what I'm hearing, is to achieve this kind of data oriented program, you should try to keep the side effects at the edges, and then you sort of inject you fetch the data you need from you do your IO or whatever, and then you inject it into the core of the program, and then it's just pure data manipulation inside. Is that So it's kind of like the imperative shell functional core.
It's very much that. It's very much that. And then what your core does, at the end, is depending, but how I model things often is that my core, when it gets a problem to solve, and it needs the user needs side effects. Otherwise, the program is not doing anything, right? But what the core does is it produces descriptions of these side effects. So that's the data that comes out is you should do these side effecty things, and then that goes out to the shell, and the shell executes them.
Okay. So a common problem in this pattern, because I've tried to architect applications this way before, in languages other than Clojure, with varying degrees of success. And I think one common problem is sometimes you have some conditional logic that says something sometimes you need to fetch something from the database, or the query, you have a bunch of queries that are sort of highly dependent on the flow of the program, if that makes sense. How do you deal with that?
Yeah, I think I recognize the pain when you get there, and it can get a bit hairy. So I guess I pay in a sense sometimes with a lot of indirection. So it could be okay, now this is data oriented, but it's a long chain of events, right? And I always know where in this chain I am. So I haven't solved that yet. But that's what I do with that kind of thing. I have an event that enters my system. I need to affect a query to a database or a query to a URL or something like that. And depending on that answer that comes back, then I produce a new effect, and that effect in turn then can dispatch data back into the system. So I change stuff like that. So it is a bit like promises in a sense. So I often call them then.
Oh, okay.
And then but it's often called on success, on error, stuff like that. So I guess that's how I do. But it is sometimes I feel like I'm paying a price for it, and I haven't really solved that. And I wish I could. I think that there are tooling in the Clojure ecosystem that I have yet to actually pick up and throw out the problem. But I'm a bit worried that if I start to use the tooling, I will just paper over the actual problem. I should maybe actually be modeling the thing differently instead of getting myself a tool that makes it easier to create mess. So
it's interesting, because I've heard other people describe their architecture in similar ways. I talked to one person who described their architecture as almost kind of the same way the Redux architecture worked for React apps, where like basically everything is events, like everything is event driven, and it's kind of the same idea that like
it's very Reduxy what I'm talking about.
Yeah, like the core idea is like your business logic can never actually perform side effects per se. Instead, it says something like, trigger this kind of HTTP request or something, and then it sort of that request kind of rotates back into the program, and like you said, like that in the imperative shell, that thing gets executed, and when that thing finishes, it can dispatch new events. Like, if it's succeeded, then like, it sends back an event that says something like, oh yeah, this it worked out fine, or like, or you get an error back. And you have a reducer or whatever you call it that keeps that tracks the intermediate state of the program, where it's like, okay, now I'm waiting, because often the business logic wants to do something with the request once it completes. So you keep some state around that sort of tells it, okay, what state is the program in right now? Like, is it waiting for a request to complete, for example? And then it can sort of react differently depending on what kind of event it gets back. But that's interesting. I mean, there is a whole I don't know. If you want, it's not always too easy to keep your programs like, elegant and functional. You would want it to be that the imperative thing is like just one request, and then you throw it in your like, business logic, and out comes one answer that you can sort of send right back to the client. But
some systems look like that, I guess.
Yeah, if you're lucky.
I'm looking at front end, but they never look like that.
Yeah. But it's something that was very interesting that you said about the REPL-driven development. Like, speaking of state, is like one thing I find really cool is that you can change the program without having to turn it off and on again.
Yeah.
And you can keep state around. Like, and I've seen there's a really cool game project called Candria that's written in Common Lisp.
Okay.
Unfortunately, I forgot the author's name, but you can check it out afterwards. But it's like very, he has this demo where he's sort of like, the program, like if the program crashes, for example, like Common Lisp has this like restart system, or condition system it's called, which means that like,
I think it's called both.
Yeah. Like when the program crashes, you can sort of repair it. Like you can say like, oh, well, yeah, that's true. I didn't think of that. And then you like, you patch the program, and then you just hit like, oh, resume, and then it keeps running.
Yeah.
I mean, and I mean, I don't think it's no accident like that. There are a lot of like game engines where either they built like a scripting language, like based on Scheme, into the game engine, so you can sort of like have this like interactive feedback loop as you're like scripting the game. Or Naughty Dog, I heard, actually like did a complete game engine based on Lisp, which is really cool. Like for the Crash Bandicoot and Jak and Daxter.
Yeah,
games.
I've heard of that too. Yeah. But was that Common Lisp that we're using?
No, they wrote their own thing. Like it was called Goal. And apparently it was like, I don't know exactly how it worked, but it was like the actual interpreter, or like I think it could compile down to like PlayStation machine code, like the whole thing, but you could like run it interactively, etc. It was a long time since I checked it out, but it's like, I don't know. I guess it goes to show that like Lisp is very flexible. I mean, it really is. It really is what you make it.
Yeah, Clojure lacks the restarts and continuations that Common Lisp has. So that's still like I would kill for those. I mean, that sounds so awesome, actually. We don't have that.
And it's like, but you still have this thing, like, where you can keep around state, etc. Like if you've ever played around with like a Jupyter notebook, for example, like, or IPython notebooks. I mean, it is like that, only much better and, like, better integrated into the whole thing.
Yeah, and a notebook, I think, is like actually run from start to finish every time. So it feels a bit similar, but it is not the same. But keeping things like the state as data, and like I'm a front-end coder, and I try to make my front ends so that the view, what you're looking at, is always like a function of a snapshot of the current state, right? So I can like run my views, put in the some version of the state, and I will see my program exactly as it would look like if it got that state. Like I sometimes use that for my unit tests. So I have like some unit tests, and it has some data in and needs to check some functions that they do the right thing with this data. But it could be like sometimes the data structure could be pretty big, so I'm not actually don't know what's in there in a sense, right? I can see. So then I can just like throw that data into my view and look at it in my running application. So I just like switch out whatever state my running application has with whatever I have in my unit test, and I can look at it. Okay, that's what I'm dealing with here. So it's very, very, very powerful when you have a front end where it is just a function of the state. So it's a lot of things like fall from that. One thing is that you actually have views that you can unit test. You have like event systems that you can unit test because actually you just want to check that kind of effect is part of whatever comes out there. You don't need to actually run that effect, so it's it's very and it gets very REPL friendly, and like when you have this, another reason why I tend to try to be as data oriented as I can, because it also makes my program very REPL friendly. It's like I can use my REPL and I can see things and I can manipulate things. I can try like alternative futures very easily, and so it's so that's reason to be data oriented. It's this interactive programming thing.
Yeah, that part is really really cool. It's a bit funny that, like, this is like Clojure is built on Java, but this feels like the complete opposite of Java, where like everything is like opaque, everything is locked down. You can't really look at anything while the program is like, once the program is running, it's like, it's off to the races. It's don't have any control.
You can catch it in the debugger, and then you can, if you have good tooling, you can look at things to some extent. But that's also a thing with this interactive programming. It is like you are in the debugger all the time, but you're just not like at the break point. The program is not still; it's like running. But you can still like look at it and look at things in your program as it is running, like if you were in a debugger.
And you can go in and inspect like every definition, right? Like, show me the definition of this, like this function, etc.
Another fun, really cheeky. It sounds like a whole. I don't know which talk it is, but it's. I think the title of this clip is just use maps. I don't know if you have seen it, but there he looks at some part of the HTTP server or client implemented in Apache or whatever, something like that, and it's like like we're talking about like common Lisp creating new languages all the time, but that's actually what's happening with these objects. Like they create like new vocabulary and everything. And he said something really funny there, because he says like, okay, so that's not the problem, the Java programmer said, because when you hit dot, like you get all these completions upright for all this vocabulary, so you can find your way through it. But he says like it's just because you created that vocabulary. Something better happened when you hit the dot, right? So it's like with the maps, there's only like business problem vocabulary that's expressed in the map. The map has no vocabulary of itself. So it's very different way of looking at it. It's very
you don't have to like, I mean, since you separate like behavior and data, so you don't have to have like data transfer objects and stuff like that. You can just like, since everything, your business objects will be represented as maps as well, and they can be like, manipulated in any way you want. You can serialize them to JSON trivially, and like you can also deserialize them, etc., etc.
Yeah.
So that's very nice.
So it is this quote from Alan Purtis, I think. Where like it's like better to have that rather than having like one object like with lots of I don't know actually. I will watch that quote, but anyway, like it's like you have one data kind of data structure, and then you have like tons of functions you can throw at the data. So it's it gets very different than what Richiki termed is plop. This where you have like place-oriented programming. It's like the program is it behaves in a special way if it is executed in this place in the program, right? So it's
and that's an anti-pattern. You don't want right. You want it to be like
according to Richiki, it's an anti-pattern.
Yeah. You want it to behave the same always. I think the Purtis quote is something like, it's better to have 100 functions operating on one data structure than like 100 data structures with one function each or something like that.
Yeah.
And that's sort of the because that's really the Java paradigm in a nutshell. Like just like you said, like every object is basically its own like bespoke programming language. And like, I mean, okay, yes, you have the dot completion, etc., but you're really just solving a problem like that you invented, that you gave yourself. But on the other hand, like, okay, now I want to play a devil's advocate for a second here.
The devil doesn't need an advocate.
So, like, I mean, the like, the dynamic typing and like the what you call it, like data oriented programming with like just working with maps and everything. I mean, that all sounds great, but does it scale well? I think many people are asking.
Yeah. Like, so obviously, I mean, it scales for the people like using it. I mean, almost every Clojure coder you're talking to is happy. It wouldn't be the case if what we were building didn't scale. So that's one way of looking at it. But of course, it's like it probably scales because of different reasons than, like, say, if you can at compile time ensure correctness of the program. So it's different. I think you need to be rigorous, like with your testing and with how you like make sure that your system has like integrity. So, but in Clojure, a lot of people turn to like dynamic type systems. They're very like similar to some of the static type systems and languages you see, but is actually running when the program runs, right? But then you remove that for the shipped program. You have this in the program while you are developing it. There is one that the Clojure core team has made. It's called Clojure Spec, and it's still in alpha, but it's widely used. But that's built on macros. So a Finnish company called Metosin created a competitor to Spec that's called Mali. That is completely data oriented. So you express your schemas completely in data. So think JSON schema in a sense, right? So it's
except you can have it like anywhere in your program, pretty much, right?
Yeah, you have it anywhere in the program, and then there are like macros and other systems that can instrument your data with this. There's some system called guardrails. So then they actually get new syntax for your functions. So you can express like the data types coming in and what requirements you have on the data coming out and everything like that. And you use like some simple syntax for expressing that. And it's actually that I think with guardrails you can choose if it's Spec or Mali that's being used. But then also guardrails takes care of it only being there in development and it's not there in the compiled production code.
I think Mali is a great showcase for the like data-oriented programming that you were talking about, because just like you said, it's sort of like JSON schema for your Clojure data, except that because it's because the schema is expressed in data. I mean, you can check your code against it, and you can also generate property-based tests from this.
Yeah.
And you can also generate like open API specs if from a Mali schema that describes like an API endpoint in your server. And like there's and the nice thing about this is that I think a lot of these are like implemented as third-party libraries, because it's just Clojure maps. Like anyone can read them. So
and anyone can manipulate them.
Yeah. So it's like, they're sort of like extensible and accessible from the outside, which I think is really it's really cool. And doing this in a statically typed languages, I mean, that's that's like, I don't know, 2 PhD students working for a year or something but with Clojure, I guess it's something you could implement after you've learned the base. But yeah, like speaking of Clojure tools and stuff, I'm gonna take us back to where we entered this conversation, and can you tell me a little bit about Calva?
Of Calva, yeah. So Calva is a plugin or extension to VSCode that turns like VSCode into a Clojure IDE in a sense, and it's I think of it as like a turnkey solution. So you can install Calva and you have everything you need for your Clojure program. So it's like it has formatting, syntax highlighting, REPL, of course, structured editing. We haven't talked about structured editing, but it's a Lisp thing. Since Lisp, everything is a structure. Then you can also leverage that when you edit things. So you're free of. It's not like line based, right? So that's Calva has like all that, and it's also geared so that like lots of new people coming to Clojure, they enter via VS Code because VS Code is very approachable.
Yeah. That's what people use nowadays.
Say again?
I mean, that's what people use mostly nowadays, I think. It's not that many people who are like, like, oh, should I pick Vim or Emacs? It's more like everyone just starts using VSCode.
A lot of people start with VSCode. In Clojure, I mean, most people are using, not most, I think 40% of Clojure use Emacs. And then 30 or 25% use VSCode. And then they use Calva because there's only Calva in a way. And otherwise they use IntelliJ and very often another plugin in the IntelliJ ecosystem called Cursive. That's,
okay, yeah, I heard of that.
It's a commercial plugin. It has a community edition, very important to say that. So if you're not using it for business, you can use it for free. But it's very polished, very... I wish Calva was that polished. So
what's your total budget, PEZ?
Say again?
What's your total Calva development budget?
It's my time. I mean, it's a lot of my time, and a lot of other people's times as well. So right now, another guy called Brandon Rinch is working. All his free time for I think a 3-month stint period. Trying to bring a better output experience to Calva. So that, I mean, that's the budget. With it's totally open source, free to use, free to fork and do whatever you want. You want with it. It's since a lot of beginners come in through this Calva gate, we have tried to make sure that Calva is very beginner friendly and try to make like Clojure super easy to get started with using Calva. So Calva has like a beginner's guide to Clojure, and it's interactive and has a lot of very easy to. You still have to have Java on your machine. But if you have Java on your machine, then you can fire up a Clojure REPL super easy with Calva. So it's not like you had that story with Common Lisp, but it was hard to get like something up, like started to use it. This should be super easy. That's the goal.
I was using Windows at the time. I remember as well. So it was just a lot of hurdles to get over. But okay, so Calva can be a really good start. So you don't have to go into the deep end and start using Emacs right away. No. But did you start this project in 2018? And did you start? Was Calva your project from the beginning, or was it
not fully? It's a very good question. So
how did it came to be?
So what happened was I was working as a product owner at a fintech, a startup thing, and the lead developer, Linus Eriksson, came from Agical. I haven't mentioned I work at Agical, so it's. But then back then I hired people working at Agical. So I had Linus, and he wanted to use Clojure for this. It's very, very, very good choice when you're working with something that needs the traceability and auditability that you need in a bank system, right? So, and very. Early in that project, another Agical developer came in, Ville Svärd, and they were working together. And we were working together a bit in a mob programming setting sometimes. And I would take my problems to these guys, right? I was a product owner. I wanted to have an idea, and I took it to them. And they took this idea to their editor and asked their editor, my mind was blown. What are you doing, guys? Yeah. And then the editor came back with an answer to my question, or food for follow-up questions and stuff like that. And then we were talking with each other, and they were talking to the editor. And after a while, what I came asking about was like real in our system, because it was built in this interactive way, like in conversation with our editor. And soon I realized that this was Clojure, actually, they were talking to via Emacs. So I was using Emacs together with them in this mob programming setting, because it intrigued me so much. And then when I was not in the mob and by myself, I had this like tiny computer, and I didn't have the help from the Emacs experts. So then I tried VSCode at some point, and it had a lot of extensions, and I think it had like 4 extensions for Clojure.
Okay.
One of them was named Clojure.
Okay.
And,
they're
so,
like, name squatting.
Yeah, it was really... so at some point I have them all 4 and didn't know if I needed that or whatever. But then at some point I realized there was one of these extensions called Visual Clojure that was actually helping me the most, because it was Clojure script friendly. But it was abandoned.
Oh, not
long story short, it was abandoned. Yeah. So I forked it, and then that's how Calva came to be. But it was very like tiny project at that part. So it's there is still like, you can scroll down the Git history and you find this
the Visual Clojure
Visual Clojure creator there. So I find that very interesting. But that's how it started. I needed something to support my use of Clojure in VSCode. And then I released it, and it immediately was a success. It was like, I don't know, if after a week I had like 1,000 downloads, and then from there just like so it's now, as I said, like 1 of 4 Clojure coders are using Calva today.
And I guess, like, if you want to use Visual Studio, then Calva is the plugin to get
on VSCode. Yeah, certainly.
And tell me a bit about the name. Like, Calva, it was not not just picked at random, right?
No, absolutely not random. It was like the Emacs where I came from. I used Clojure. First was with Emacs, and there they have this system called Cider. And I wanted to create Cider for VSCode. And I don't know if you know, but the way you do Calvados is that you distill cider. So that's why I call it Calva.
Yeah, no, I like the name. It's very clever. I like when there's some like lore behind the name.
So I see it in the tagline of, if you go to like calva.io, you see like distilled from cider. So that's the name, and that's also like the spirit of it. Even if like we have a bit different ways to approach like how we Emacs and VSCode are very different environments, so it's different approaches maybe to users. In Emacs it's more like a lot of assembly required, so that's not what I want with Calva. I want no assembly required, but you can. It's very configurable, so you can configure Calva a lot, but you shouldn't need that just to get started.
I get what you mean. It's like, feels like it's like a bit of an age thing as well, because I remember, like, I don't know, when I started with Emacs and stuff, maybe like 15 years ago, like the fact that you sort of almost had to tinker with it was not really a downside for me, because when you are young, you have a lot of spare time. It's like, okay, you're telling me I have to, like, add learn like Emacs Lisp just to get started with this. Like, okay, let's go. But now it's like I just want to solve problems. Like, and ideally, someone should have already solved them for me. I mean, so I can totally sympathize with that. Like, just wanted to be ready to go out of the box.
Yeah, I also love like to tinker. And I'm in love with the Emacs idea, like that this system under your fingertips, and you just evaluate some Lisp thing, and the whole editor behaves in a new way. I mean, it's very like this idea with interactive programming. It's there, but you actually have that in VS Code today as well, thanks to a thing that we talked about, Mikael Borkent before. So Mikael Borkent and I did another extension to VS Code called Joyride. So with Joyride, right, you get user space scriptability of VS Code. So you can just evaluate Clojure code to get VS Code to behave in new ways. Very Emacsy in that sense.
So you can turn VS Code into Emacs.
Bit of this Emacs philosophy into VS Code with Joyride. And it is a much nicer language. I mean, eLisp is cool, but it's not a really nice language.
It is a little bit weird. Like, it has like dynamic scope and stuff like that. But yeah.
Still have dynamic scope? I thought they got rid of
so. Okay, maybe. Yeah, I haven't touched. I'm mostly a Vim user now. Don't tell anyone. But so what's up next for like Calva? Do you have any like thing planned for like a new version coming out soon, or?
Not a new version, but as I mentioned, Brandon is working on this better output experience, because that's a bit of a sad story with Calva. It's not really coping very well when gets a lot of output. So that's like on the way for Calva. But another thing that I'm starting to do now, so it's just a week old or something like that, but I already have a working like proof of concept. It's an MCP server for Calva.
Cool.
So I'm building that as a separate extension, and it's using like Calva's extension API to give the AI agent access to Calva. And the first thing that I have exposed to the AI agent is the Calva REPL. So it's fundamentally turning the AI agent into an interactive programmer. So it can evaluate things against your living, running program and modify it. And not just throw code at you that it says, this code, use this code, it will do this. Now it will actually try that a few times and make sure. I made this code, and I tested it, and it does this. So it's very different. It's actually pretty crazy to look at it using the REPL.
Yeah, very cool. So, like, and how does this work? Like, when you're actually using it from like VS Code, can you do you integrate it with Copilot, so you can sort of tell Copilot to do this, or how?
Yeah, so Copilot has this discovery. So you can give it like configuration. Say there is an MCP server over here, and and that's basically all you tell Copilot. And then Copilot will query that MCP server and ask it, what tools do you have? And this MCP server say, I have one tool. It is evaluate Clojure code. Okay, fine, says Copilot. And then Copilot is smart enough to know when it needs to evaluate Clojure code and use that tool. But you can use Claude, desktop, whatever, and just tell Claude that you have this Calva MCP server, and whatever agent that is supporting MCP servers, and it's all the rage now, so most of them do.
That's very cool. Like, so I know you said you just started this, but do you have any kind of like ETA for this, or like how much more do you think? How much more polish do you think is needed before this could?
Not much. I don't know. When do you think this podcast is going to be edited and out?
I don't know, 3 weeks from now, maybe.
Okay, yeah. So Calva MCP, the first version 1 of that will be out when people hear this.
Oh, very nice.
And then they will find it in the extension pane inside VSCode, because it is a VSCode extension.
Very nice, cool. I think we're about time to start like rounding up, but I think one thing I wanted to ask you is like, what would be a good way to for people who want to start hacking Clojure? Like where should they start? Like what's a good starting point?
Yeah. I have to do some like shameless self-promotion, but no, a very good place to start is actually VSCode, Calva, and then you run the VSCode command, Calva, fire up a getting started REPL. And then Calva will create a new project, a Clojure project, and it will start its REPL, and it will connect to that REPL, and it will show you 3 files, namespaces. One introducing you to Calva, one introducing you to Clojure, and one introducing you to structured editing. So it's I know lots of people that have like started with Clojure using this getting started experience.
Okay, so it's like it's like a tutorial level that starts.
It is tutorial. It's very basic. It's take Clojure from the start, and I'm not even finished with that guide. It's like a file of 2,500 lines or something like that, and it just covers like 10% of the story. I actually would want much more there, but I don't really have to, because people get started and then they can explore Clojure in other ways. So there are a thing called for Clojure.
Oh yeah, that's a good one. Is that so still around?
Yeah, so it actually died, but then it was like resurrected again using Babashia, and so there is a web version of it that you can run that will run the Clojure code in your web browser actually. So it's very self-contained there and nice. There is also a version for Clojure that you run in your editor. That I did. So then you use like the Clojure editor and interactive programming instead to solve these for Clojure puzzles. So that's a way. And the thing that worked for me, because I think that what's hard for me to enter Clojure was actually to reprogram myself to be more functional, to think more functional. So I was very imperative in my thinking, and that took me quite a while to get to where I was more productive in Clojure than I was in JavaScript. So, but then I used Advent of Code and used Clojure to solve Advent of Code problems, and that helped me a lot. So that's another thing.
Then you have something like a real assignment that you actually have to solve with
you have to solve it, and I knew how to solve it in JavaScript or some other language that I knew, so that I could like experiment that way. But I would force myself to use Clojure to solve it. And there is a excellent channel on Clojurians. You can ask people
the Clojurians. We should mention like there's a quite active like Slack channel called like Clojurians. Or how do you join that?
Clojurians.net.
Okay. Yeah.
You go to Clojurians.net and you can join that way. And then it's a it's a Slack team. I think they are called, right? A Slack server. And then there are lots of channels in there. The one I mentioned now was like the one called Advent of Code. But there is also a beginners channel there that is full of like experienced Clojurians that love to help beginners, because it's a bit of a sect in a sense. We want more people in, but so it's very beginner friendly, the community. So you get a lot of help there, and then there are Clojure channels and Clojure script channels and channels for all the major Clojure tools that people use.
Yeah, you definitely want to be in there, I think. Yeah, it's interesting. I think what you said about like how you sort of have to rewire your brain a little bit, because there's like another thing about Lisp is that even though it's so simple, like I mean, if you really dig down, and I think another cool thing you can like some reading material is like Paul Graham has this interesting essay on like how to build Lisp, and it's like only I think like 4 or 5 core primitives that you need, and the rest you can sort of like build up with macros from there.
Yeah.
But even though it's so simple, like a lot of people have a hard time learning Lisp. But maybe it's because of what you said, like you sort of have to rewire your brain to think more functionally, to have like a good...
Yeah, I think for me it was the functional thing that was hard. Not so much the Lisp part. That was...
Yeah, the parentheses.
That was okay, because I've been working in PostScript for 3 years of my career. It's very similar to Lisp, even though it doesn't have parentheses at all.
Yeah, but it's a stack-based
reverse polish thing. Yeah,
it's a stack-based language, right?
Yeah.
How come you were working with PostScript?
Yeah, I was working with like business graphics for in like marketing research business. So I was producing business graphics on like these plotters at first, but then the laser printers and stuff like that came, and some of them had PostScript, and then I started to do it in PostScript, and then instead of, it was very profound for me, because I had been using data, right, the results of this marketing research, and then I had made programs in C and awk and every kind of programming language you can think of to produce like instructions for the plotter. But that was also, in a sense, data. It was just a move the pen there, put the pen down, whatever, like turtle graphics thing. But then when PostScript came along, what I did was more like send it the marketing research data, and then there was a PostScript program in there doing the drawing. So it was very, I think it was very interactive programming like, and very data, very data oriented. So I think I really loved it, and thinking back, I know what I loved it about it, because it's the same thing that I love about the systems that I work with now.
That's very interesting. You sort of circled back to the beginning almost, like so also like homoiconic and also like interactive programming and like all of those like Lispy things.
It's old ideas, right? That actually like still like were super good then and still are super good ideas today. That's how I see it. The Lisp is a super good idea.
Yeah. I mean, it sort of keeps coming back, and I'm thinking of this. I think it was wasn't it John McCarthy, like the guy who came up with Lisp, that sort of said that like he didn't really invent Lisp as much as, you know, discover it.
Yeah, I guess.
Yeah, so it feels like
that must have been a very nice feeling, discovering Lisp.
Yeah, and I mean Lisp is sort of like came out of the Lambda calculus, right? Of like Alonso Church, so it's like it's like yeah, all the way back to the beginning of computation, pretty much. But yeah, I thought we should also. It would be amiss not to mention some of the great like Clojure content, because I think like Clojure has some really good videos and presentations. Like I mean, and now I'm thinking mostly, of course, of Rich Hickey's seminal "Simple Made Easy" talk.
Yeah, everyone should watch that one. I mean, it's if you want to watch one programming talk ever, I think that's the one.
Yeah. No, yeah, and I mean, it still holds up, I think. But even like when he came out with it was like I remember that the really hot thing was like Ruby on Rails at the time, which was like it's very object oriented, very like how can I say it? Very antithetical to the thing about Clojure. And he was just like ORM stuff like that. It's just a no, really good. And I remember James Reeves. He has a really good talk about like building like domain specific languages and stuff and like data oriented programming, etc. I will link to it in the show notes.
There is one talk too, or if we're like thinking about like beginning like introducing to Clojure and the thinking of Clojure, is a video called "Solving Problems the Clojure Way."
Okay.
It's by Raphael Dittwald, and the interesting thing is that the whole talk is in JavaScript. So you don't even need to watch the parents and Lisp or anything. You will learn to solve things the Clojure way. But he's doing it with JavaScript. It's an awesome talk. It's
do you have any more recommendations for like good Clojure content, even if it's like stuff that's not beginner focused?
Yeah. So there is my favorite Clojure tool. It's called Replicant, and it's like React in a sense, but it is not React. It's fully data oriented and functional in a way that React isn't. And the guy that makes Replicant it's Christian Johansson. He has like two channels on YouTube. One where he does together with Magnar Sveen called Parents of the Dead.
Okay. Parents of the Dead.
Parents of the Dead, and they build some kind of zombie game using Clojure. And yeah, it's amazing to watch. And it's not like beginner level stuff, but I think if you're a beginner, you can still watch it and just like get whatever you get from it, which is super good and super entertaining. But he also has so Replicant is kind of new, so he has created a site for Replicant called replicant.fun, and he has also started this channel, Replicant channel, and he has started with the 7 GUIs challenge.
Okay.
So it's a challenge that you do with lots of front-end systems. You have 7 GUIs to solve, like increasingly complex, or touching at different things. And he has like done the three first of these GUIs. It's amazing content. I can really recommend that. And then there is a YouTube channel called Fred Overflow.
Fred Overflow.
Yeah, and it's I love watching like the Fred Overflow things, and he's very rigorous when he solves some problems, but it's doing it like iteratively. And one of them is about performance, and it shows how like, and it's about these lazy sequences actually. So he shows how to approach the problem, and he like 20x the performance of the thing step by step. So he's really, really good. And everything by David Nolan.
David Nolan. Oh yeah, he's a household name, right?
He's the steward of ClojureScript. And he is also the creator of several cool libraries for Clojure. I think Core Logic is of his making. Core Match is pattern matching for Clojure, and a lot of. And one of his talks is called "Everything I've Built is on the shoulders of someone else," something like that. And he one part of it is about Core Match and how it takes ideas around like effective, super performant pattern matching and implements them.
Okay.
So it's super. And then another one is like ClojureScript in the era of TypeScript or something like that. It's also very everything by David Nolan. It's just super. It's a bit like everything by Rich Hickey.
Yeah, Rich Hickey, David Nolan, just, search for those names on YouTube.
I throw Christian Johansson in there as well.
Like I said, there's lots of really good like Clojure content, and you can see that it like Clojure really attracts, like you said, like it's a lot of people who are very, very, very passionate about the language and like programming in general.
Yeah.
But
you can see how productive people are, because even though it's a small language, small community, the ecosystem is booming. It's like new things all the time. It's amazing how if you build with Clojure, you're like so well provided. It's amazing.
Yeah, and also like the from what I've heard, like things stay very stable. It's not like we
haven't mentioned that. It's super stable. So I don't know where you want to edit this into the podcast, but it's super important, because in many programming languages, like if you want to update the dependencies of your program, and one of the dependencies is the language itself, and then maybe some other dependencies. That's a pretty scary thing. You have your day of work in front of you. You're going to do that, but that's not the case with Clojure. You can just update the latest Clojure, update all the dependencies to the latest, and like it's very, very rare that you need to do anything about your program. It will continue to work as before, even if the program is 15 years old and you haven't updated it in 15 years. It will still be the same story, because it's very like you accrue changes in Clojure, and in Clojure it's a culture in Clojure, in libraries as well. So you add things to the program, and requirements are like loosened, never tightened, right? If some function has requirements, then it's okay to loosen the requirement. It's not okay to tighten them. So if a call that was valid at one point should remain valid, and I think it's the very thing that Clojure is not Rich Hickey's like playground for cool ideas that it has. It's like it's a place where he has played the ideas that he really believes in, and he has set them in stone. So it's super stable, and that's one of the things that makes it so fun and pleasant to work with.
And is this because there's, I mean, I guess part of it is philosophy, like you said, but do you think part of it is also because like the core itself, it's so small and like, you can sort of add new language, a lot of language features can be added through macros, for example?
Yeah. So Clojure grows by libraries, as we say. So that's definitely a part of it. It's very like tiny core, but it's also very rich. So but it's definitely that. And also, I think it's a tradition of this, like coming from Common Lisp. Common Lisp was one of Rich Hickey's like inspirations when he started. And I think it's the similar story in Common Lisp that a Common Lisp program, like it did its work. At some point, it will continue to do that like going forward. I don't know if it's as powerful and extreme as it is in Clojure, but I think it's the same culture.
But it does feel kind of like that way. Like, I've noticed in the Clojure community that like some people, like, sometimes the library is just done. And it's not like, and, if a Clojure library, it hasn't been updated in like 5 years or so, people are like, oh, nice, that must mean it's done. But
yeah, exactly. If you meet a JavaScript library at that, you wonder why this is abandoned, right?
Yeah, or like, in the JavaScript ecosystem, if something hasn't been updated in 5 years, it doesn't mean it's done. It means it's broken. Like,
something is wrong with it. There are exceptions, really, but
I mean, you literally probably won't be able to use it because, like, it's going to depend on something that has a major version that is incompatible with something else. And it's like, it's a mess.
Yeah. You're right. There's connection there between this stability and the doneness. But the doneness also comes from like another part of the culture that is like things are very like focused. It's very much libraries over frameworks, and so the libraries do one thing really, really well, and that means they can be done. They can reach the done state. But if you have some framework, right, it's like continually evolving and stuff like that. It's never done. So it's So I think it's two parts to it. It's this very focused, small, powerful libraries, and also this culture of never breaking your callers. Never break your callers.
Yeah, I mean that's a good more ecosystems should adapt that philosophy. I think.
I really hope that would be super beneficial.
Yeah. I mean, I work most with .NET nowadays, and like every major version of .NET is always with some trepidation you upgrade because it's like okay, this is going to break something, and it's like those releases, those new .NET versions, they just keep
that's
coming.
Interesting because that's what it could. Java is very stable. I mean, very backward compatible, even though they like develop Java in some lightning speed right now. It's still everything is very backward compatible. Right?
Yeah, but again, I think it's more like a philosophy thing, because like I think you could achieve exactly the same level of backwards compatibility. It's just that people like I mean, you're so dependent on the runtime and the host language for new features. So people like in this new like major version of my library, I want to be able to use this fancy new thing that's in the new version of .NET, and I'm going to force people to upgrade so I can have this, like so I can include this in my program. But again, like you said, that's a function of the language not evolving through libraries mainly, but like through the runtime and the underlying platform. So more languages should take a page from Clojure's book in this regard.
If you take one page from Clojure, I think this part of the philosophy with being a very stable environment that you can trust. I mean, that you can trust you're not going to be broken by this language going forward. That is actually super awesome.
That's very nice. And I have a final question I would like to ask. That's kind of in the like part of the show's format, which is, what do you think the future of programming will look like?
That's a very big question.
Yeah, it's like you can do what you want with it.
Yeah, but it's very, very, very hard to say. I think like AI will be part of it. That's definitely the feeling I get. But it's also hard to know where we are on that. Like, I mean, right now it looks like everything is going to the sky. But if we are at close to some plateau, and maybe it's a different future than if it continues. So it's hard to say from that point. And yeah, I really don't know where the future of I know where the future of my programming will be. I mean, it will be probably in the Clojure sphere. I don't see myself. I used to see myself as a polyglot programmer. I could learn any programming language, but when I found Clojure, I was at home. So it's very
the last programming language.
And I think like I will go even more data oriented as I go forward. That's a bit of a new thing for me in my development as a developer. So more and more data oriented, and I do think I see a bit of that actually entering. It's not just in Clojure. I see that also in JavaScript libraries. Sort of that. It's when you find these really nice JavaScript libraries, it's very often super data oriented stuff. So I think I definitely think I see a trend towards data oriented functional over from the imperative. So and that's maybe it's more hope than something else. But I think also there is something to it. I saw Dave Foley, is that his name?
That sounds familiar.
Yeah, like he's very big on continuous integration stuff like that. But he also does like general programming things. But he made some like video like in defense of object-oriented programming. And I guess that's a signal, right? If someone feels the need to do that.
If they're retreating, trying to defend
FP is coming, right? Threatening.
Yeah, but I mean, it does really, like, now when you mention it, it does feel like a lot of languages, they're sort of coming around to this idea, like both like C# and Java has like record types now, so you can sort of program in a more data-oriented way right out of the box without having to like
and immutability as well, right?
Stuff. Immutability. And C# has link, Java has streams now, so it's like I think people are sort of realizing that, and I think that some people sort of like it's easy to conflate OOP and like procedural programming as well. Because I mean, if you listen to like Alan Kay or something, like, you know, when he says like, you know, when he coined the term object oriented, like he didn't have C++ in mind. I mean, and it feels like most of the languages that are popular today sort of sprang out of those ideas. Like, you know, it's basically, you know, it's procedural programming, and then you sprinkle a top of like some OOP on top of it, so you can have like abstraction boundaries and stuff like that.
Alan Kay's thing was message passing. That was the core OO thing, I think.
And I mean, Smalltalk is much more similar to something like common Lisp, at least in my world, than I don't know, Java or C#, because he also put a lot of like emphasis on it should be dynamic, you should be able to like interact with the system, etc. So a lot of those like Lisp values, except that like if you think about like Lisp, in the Lisp main primitive is lists and functions. In Alan Kay's world it was like objects and messages, but it was like same idea, almost like not quite homo-iconic, but pretty close. And also like you can do a lot of crazy like meta programming, like you can have the this is, I can't let this become like the small talk podcast, but it's like the small talk editor is almost kind of like Emacs, like the small talk editor is also like part of the small talk system that you're operating with. So, and you're defining classes by sending messages. So it's like very, very like meta.
There is an editor in the works like that for Clojure called
really? Oh, okay.
Yeah. So it's it gives you strong like small talk vibes when you look at it, and Emacs vibes. So it's like the whole system is like at your REPL fingertips, and so it's easel. You can look it up. There's a channel. It's very rough at the moment, but
okay. So easel is also written in Clojure.
Yeah.
Okay. Oh yeah, that's very, very cool. Like you get a lot of interesting properties that way.
Among the cool things, easel is among the absolute coolest things.
Okay, so yes, check out easel and check out Calva. And
we can maybe put an easel video in the show notes.
Yeah, definitely. All of the links will be in the show notes, and like lots of cool Clojure content to dig into. Yes, so I think it's time to wrap up. But thanks a lot, Peter, for coming on the podcast.
That's been a pleasure.
Yeah, it's been a pleasure for me too. Like to get some like dynamic. Let's silence the dynamic programmer voices on this podcast, I promise. Okay, thanks again.
Thank you. Talk later.